Hello everyone. Today I will do a lesson on testing. And before I do anything, I will first announce this. Announcements. Should probably announce soon. In learning discussion. TDD. Oh crap. And got announced. Good. All right. So today's lesson is to talk about testing. I'll try to grasp essentially what testing is, what parts does it consist of, why is it so needed, and what's so good about it. So I'll also try to cover alternatives, different types of testing. I'll try to give a few demos of how testing can be done. So this is not absolutely included or coupled with object-oriented programming, but it's definitely a nice thing to be aware of. And I hope that this lesson will result in you, a developer, caring a bit more about having tests in your project, because it's a really big difference when somebody has no tests and when somebody has tests in their project. It shows not only care for quality, but a slightly higher level of skill. So, let's get started from a general part. And I'll be jumping between two slides, two different slide sheets in here. So let's go. Now, testing is important for several reasons. And it might be weird to hear that testing doesn't only matter for having a control over your functionality. It's not just to check if it works. It's many more things than that. Tests, first of all, is a specification for how your code should work. Basically, it's a living specification because you add tests, it means that you add specification to how stuff works. Imagine if you're a new person working on a project, and imagine that suddenly you have to work on a new project. And it might be hard to get used to it. It might be hard to take over a new code base, but and what do you do to take over a new code base? You read code, you try to figure out, you do the clicking and stuff like that. That's cool and all, but there is another way. With tests, you have exactly the things you need to do to make the code work. You have the steps that you need to call, you have examples how to use code. So it's like a tutorial area even for new developers who join the project. It's like a playground which they can use and see how stuff works. Hello, Chancellor. So, tests are first and foremost for code quality. Secondly, they are for empathy for another developer. They join, they see the tests, and they can get into project easier. They can understand how it works easier. Hello, Hannah. Oz Mandiazzi. Okay. Butchered the name. All right. So next thing about tests is that, of course, it gives us control over what we have. It lets us change stuff. With tests, we're not afraid to make changes. We're not afraid to refactor stuff because it's tested. If we make a change, we run a test. If it passes, the change didn't break anything that we had. If we didn't have tests, we would be afraid to do any changes because it could cost more than it wins. And last but not least, with tested code, not all code can be tested. And when code cannot be tested, it should be a red flag, a signal meaning that something is wrong with the code base. When we write tests, we need to think about what needs to be tested, and we need to keep it small. Tests should not test everything. Probably even Chuck Norris wouldn't be able to test a whole application with a single assert. And so we should test a feature, in my opinion. A feature under test is ideal, what you should go for. And in order to test a feature, it shouldn't be coupled with any other things. And so in order to decouple things and which have no side effects, and in order to make things testable, it's a skill. And it needs to be well designed. And tests basically enforce the design, which lets stuff to be tested. If you miss, let's say, a bug in development and it goes through all the other layers of QA and ends up in production, it will cost you a lot. And you don't want to pay for your mistakes. So tests are cheaper in terms of how much effort and time and resources you will have to invest for fixing something that is later down the production pipeline of your code. That's why tests are basically a must in any organization that cares about their customers and that has a longer lifetime for their software. It just pays off. Simple as that. And it doesn't really take that much time, and that's a misconception. Testing doesn't take much more time. It's a misconception. When we test stuff, we want to test a single thing, a unit in other words. And there are different kinds of tests. There are unit tests, there are functional tests, there are integration tests, and so on. But when we test a unit, we ideally don't test neither a class nor a function, but we test a feature. If let's say a thing that we have under test it gets refactored and the result is another class, a few more functions, we don't have to test those functions because we already tested a high-level thing within our test. So it's already covered. You don't have to test everything. Test coverage 100%, in my opinion, is a little bit of a BS because that's not what you should go for. You should go for every feature tested, but not every little bit and piece of code tested. It might give a false sense of security. Just focus on more extensive tests for feature rather than all tests, but not so perfect for every bit of your code. When you have to test stuff and when you depend on something that you don't want to depend, let's say when you depend on random numbers, you should mock those random numbers in your tests and make them hard-coded so that you are in control. Being in control is very important. Here below you see an example of what I meant with mocking. Here I used mockU, and it basically mocked random class. Random is a class which generates random numbers in a range. So by saying setup and saying that next for any int should return 0, it means that when I call next, in my code as a dependency, it will return 0. Do you remember dependency injection principle? Well, random is actually a dependency, and it shouldn't be something that you hard code and keep it created and not injected within your class. It should be passed from a constructor, preferably, because it's a dependency. If you want to make it testable or escape this dependency, you need to inject it. There is no other way to escape it otherwise. So if you want to test something that gives random numbers, you will have to inject that component which randomizes random numbers. Another reason when we test heavy things, we also need to escape a dependency of heavy things and just hard code the values they return. We don't want and we don't need them to return something for reals, because when we test a feature, something has already been tested and we don't need to test it again, so we can mock it. That's what unit tests is all about. We test a single thing, a single feature, and nothing more. And that's why we can allow ourselves to mock stuff. Integration tests will test the full thing, and they will be significantly slower for that reason. But integration tests are also needed because they show if code works for reals in full combination with other components. And how does it look like when you mock something which takes a long time to, let's say, process? In this example, we have a file reader, and file reader loads, let's say, a big array. Let's say you pass in an array of strings, and those array of strings are a bunch of files that needs to be parsed into a single string. And that could potentially take a long time. But with mocking, for testing purposes, you don't have to parse everything, and instead you could simply say that every file contents are hello world. And so when you parse it, you'll just get a bunch of hello worlds for different files. And the end result is that when you pass a bunch of files into the stats processor and get the most common word, you can find the most common word. You know what's in the files. You mocked them. You hard-coded the values. And it didn't take much time. You didn't actually open the files. Stats processor is what we test now. Not reading files, but processing the contents of them. That's why it's irrelevant if reading works. It's already tested. There are a few types of testing: white box testing and black box testing. White box testing means that we test everything. It's basically mocking. When we test everything, it means that we're not satisfied with just results of a test. We're not just satisfied with the output. We also care a lot about what happens under the hood. So, if we go back to this example, this is black box testing. Why is this black box testing? Because we just pass an input and we check if the output is the same. Now, if this was white box testing, we would also check if certain methods were called, if certain pieces of code were touched, because that's what we also care about. It might be just a coincidence that we happen to get the result that we needed, or that it won't influence much if the result will be what we want, but sometimes a certain pieces of code have to be touched, and without touching them, it wouldn't throw an error, it wouldn't modify the end result, but it would affect something indirectly. And that indirect result is what we sometimes might not be able to grasp through a test. And so white box testing can grasp it. You can hook into a piece of code and assert if it was called or not. Not to check if some result was returned, but simply to see if code was called or not. So, for example, a real case scenario is if you send money to a bank, it's not enough to just check if bank received your money. It's also important to see if all layers of security were passed, if your account was valid, if bank also validated the account, if third-party stuff validated it. It's not enough to just check the account balance after the transfer. It's also important to check the security layers. And in other places where pieces of layers of code, the flow is important, it's important to prefer white box over black box. Black box is very simple. You have zero knowledge about the application. You just shove some input and expect some output. And you assert it. Black box testing should be the dominant kind of testing, and it should be an attractive way to test things. Because it's very easy to pass input and expect some output. I mean, we usually tend to know what we have and what we need, and the how to do it, comes later, way later. And that's not a bad thing. So black box testing is what leads to test-driven development. And we'll see why. So black box testing would be if we have no result after our effect, after doing something, we have side effects. And those side effects we can still check. For example, if we create an account, it returns a void. But if we select an account by the created account ID or the latest account, we should get one account if it succeeded. If we didn't get an account, if it wasn't found, then it didn't succeed. Integration tests are just something that you do the same but don't mock. Now, testing frameworks. You have MS Test. That's the worst choice. That's the default testing platform for .NET, but it's not that old. It's actually I think 2007 or so it came out. It's not that old, but basically the story behind MS Test is after XUnit came out, Microsoft wanted something of their own, and so they made MS Tests. And so NUnit is the oldest, most featureful testing framework, and XUnit is the newest, less featureful framework, but it's better than MS Tests, and it offers an object-oriented approach to the way you write tests. You will feel at home if you like object-oriented programming with XUnit. You have facts and theories, and it really doesn't like verbosity of other kinds of tests. In all other frameworks, in order to test, you'll have to put a test class or test fixture attribute above your test, above your test class, just to run it. And with XUnit, you don't have to do that. All you have to do is to mark your methods as facts or theories, and that's all. Fact is a test that doesn't require input. I mean, you do something and it will always, with all kinds of input, with the same kind of input, with different input, it will give you the same result. Theory is something that depends. I mean, I assert if I give this, I expect to get that. If I give this, I expect to get that. So with theories, we have input. With facts, we don't. And XUnit is basically just facts and theories, which is very intuitive to understand. Now, I won't cover this, but I would like to move to TDD and then we will move to other slides. So TDD is test-driven development. And TDD doesn't mean that we just write tests. It means that we write tests first. First, we write a test, and then we write a thing that we need to test. And this kind of approach enforces 100% test coverage. And this is how it works, how TDD works. That's the flow for TDD. And it's called red-green refactoring. You first write a test, and then you implement a feature for that test. So how does your test look like when you first write it? You know what you have, so you can create it. You know what you need to do, so you can call it. And then you know what you need to get, so you can assert it. And all those that you call or create will be unimplemented, so it can be just interfaces or features which throw an exception. So you run such tests and it fails. And then you need to fix it. In other words, you need to implement the feature that is unimplemented. And so in red-green refactoring, it means that you throw all resources into simply implementing a feature. You don't care about quality at first. You focus on that it simply works. And that's called duct tape programming. Duct tape programming might sound like a horrible thing, like a thing that you shouldn't be doing, but in fact, it's a really nice thing. Focus on the result first. Make it work, and then focus on fixing it, refactoring it. After you're done with refactoring, you can finally commit. The problem with duct tape programming and duct tape programmers in general is that they end their cycle in step 2. They implement a feature which seems to work and they're fine with it. You shouldn't be fine with a working feature. You should have standards and you should follow those standards, and only until those standards are fulfilled, only then you should commit your code. But test it as is. Don't try to make it perfect before you test it. Just make it dirty, make it fast, and test it. If it works, then make it pretty and test it again. And if it still works, commit it. When you write a function and you see that something is not working, but that something is not a usual case, you should write another test which covers the case which failed. And so whenever you see a faulty case, you write a test. And then you run the test, you fix the case. And so you test, and for each broken case, you write another test. And when you cover everything, you can finally commit and say that it's 100% covered. And I feel that I trust my code and that it's well tested. We won't talk about BDD now. It's not that important. We also won't talk about UI tests, and let's go to other slides. So there are 3 frameworks and essentially 3 steps that you should care when testing. And those 3 steps are very simple. It's simply set up, act, and assert. We build something, we do something, and then we check if something that we expected works, is right. Setup is just initializing test data or components under test and configuring dependencies. And in these slides, I'll check how Hatchery should be tested. Hatchery is made of chicken. Chicken lay eggs, and for a chicken to lay eggs, a chicken needs to eat a certain amount of worms. So setup would be create a chicken and worms so that the chicken can eat worms. act would be a chicken eats worms. And after chicken eats worms, it outputs an egg. So input goes to chicken, which lays an egg, which outputs, well, which eats food by laying an egg, and that outputs an egg. And our assert would be that we check if after eating a certain amount of worms, a chicken laid an egg. So if an egg was broken, and if we asserted that it was clean and good, then our test fails, and we'll see test as red. Clean tests, or in other words, how tests are supposed to be like, are fast, and they have a single thing under test. And another important aspect for clean tests is that they are reproducible. In other words, if I can run my tests, then my colleague should also be able to run my tests. And if I run a test once, I should be able to run it twice as well. The problem with this is, for example, if order of tests matters. It shouldn't matter usually. Or if let's say I create an element with a certain ID in my test, and then I create it again and it fails because it already exists. Well, tests like that should not be existing, and you should clean after yourself. You shouldn't keep a test with a state. Hello, Dukestein. You shouldn't have a test with a state. It should always be a state. It should always clean after itself, or it should be stateless in the first place. So for example, if you have a database, and if you create test if record was created in a database, you have a few options. If you're making a unit test, you should mock the database out. You should mock the connection out. You should only have stuff in memory and not actually try to connect to database, because it would simply be too slow. If you have an integration test for database, instead you could start a transaction when you're inserting something and simply roll back transaction when insert is done. That is good enough, and that will have no state in your test. If things are not well designed, and let's say if transaction cannot be supported, then you will have to clean after yourself explicitly. In other words, if you created something, you'll have to delete something after the test is done. So tear down is an extra step that you might have to do, and in the cases I said, tear down might be rollbacking a transaction or deleting a record that you created within a test. You want to keep the state clean. No state is good in tests. And now you might ask yourself, what do we actually need to test? And you might think that testing a function, a feature, if it works, is enough. But it's not so simple. Testing if it works is not enough. You should test if it fails as well. If it can fail, you should test if it fails when it should fail. If its behavior varies significantly, I mean, if output is not just a different number, but a different way how you calculate a number, you should test that too, even though that's the same function. You should test all that differs significantly. I mean, if it's the same function, you should add a separate test case if it behaves differently based on an input. So, for example, I have a method called walk on a chicken. I could just say walk, test walk, and check if chicken moved. the amount of distance I expected. Would that be enough? Well, maybe. It depends on specification. If chicken can be scared, if chicken can walk normally, well, consider this specification. When chicken is in his normal behavior, he walks normally, like a meter a second. When chicken is scared, he walks 10 meters a second. But when a chicken is scared, he also has a chance to fail walking, to trip, to fall, to start flying, which influences the way a chicken walks. So now we have three very different behaviors, but a single function. And all of those behaviors require a test case of its own. Not just different input, but a test case of its own. And when we have those test cases, we know that a chicken behaves differently when he walks. He can walk normally, and it always succeeds, and he always moves this much. But when he walks scared, he can fail, but he moves faster. That's what a test would show us, and that's very important. Test suit is like a bunch of methods related to some object. And in this case, our object that has a relation to test cases is a chicken. So a chicken is like a test suit, not a hatchery, but a chicken. A chicken is a test suit which holds all the things, all the behavior that a chicken can do. So you could consider test suit a class which tests another class fully. Again, single responsibility. If your suit is very big, if the object is very complex, well, then you can have, let's say, a suit for eating, a suit for walking, a suit for sleeping, for different kinds of methods, if it is worth it. Normally, the way I test, the way people test, a class should have a suit of its own. So, in order for a test suit to be understood, to be read by testing framework, it has to be a public class. Not a static class, a public class. Private, if it's private, reflection won't be able to read it. Tests are based on reflection. Based on the attributes, based on the access modifiers, when you explore your tests, when you want to explore your tests, tests won't be read if they don't have certain attributes or if they don't have a certain access modifier. And now let's go back to the testing frameworks. So more about each. When .NET came out, it came with XUnit, and ever since 2000, it was the framework in Visual Studio. XUnit is multi-platform. It has support in basically every other language, and it's a pretty damn good framework. I mean, it's maybe my favorite, but I have a competition with XUnit and XUnit. It's a really good framework, and it's the most featureful. MS Test is another one, which came 5 years later, and it was actually a disaster when it came out. It was simply Microsoft trying to be Microsoft and compete with what already works and does a good job, but Microsoft wanted something of their own, and so they released MS Tests. It was slow, way slower. And also it was not so good. It didn't have many features, and it was simply lacking. But and so for around a decade it was abandoned. It didn't have features, it wasn't updated, the community was pretty much dead for it. But then 12 years later, a new release came out, MS Test 2, and now it does compete and stand against XUnit and XUnit, and it's okay, it's not bad. And now as of today, it's maintained, it's pretty good. but still lacking compared to other two. XUnit is, in my opinion, the beast, the best, and it's awesome if you like object-oriented design. In 2008, it came out, and, well, it was made by the same guy who created NUnit in .NET. So, it was a good thing. XUnit is very simple, easy to understand, and intuitive. If you seek for those things, that's a no-brainer to use XUnit. Fluent assertions, we don't care. Well, the thing about testing frameworks, tests essentially don't differ. And I really hate when people say that, oh my god, your course is saying unit tests, software testing, but it doesn't say what testing framework they use. That course is a scam. It's useless. It's bad. No, it's not. The concepts are all the same, and it's very easy to move from one testing framework to another. Tests essentially are the same. If you look at the implementation of tests, you'll end up seeing the same things. And if you use a library on top of your tests, they will be actually the same, other than the method definitions or class definitions. In other words, other than those key methods, the definitions of them, the test case, test suite, tear down, and setup methods. So let's look at this example. This is a Fluent Assertion, a library used for BDD, behavior-driven development like assertions. And it just means that the way you do asserts, you don't assert, but you do it in a human-readable way. So look at this. You create a chicken, you create worms, and you say, a chicken lay eggs. And then you say that eggs should not contain nulls and contain, and each egg should be, or at least one egg should be okay. That's my test. And all of those conditions are very human readable. Here is a chart of comparison of each test thingy of those different frameworks. So what you need to do to recognize the test, what you need to do to run those special steps of test, and what you need to do to make them parameterized. And as you can see, hands down, XUnit wins in most cases, as it is more simple and intuitive. And I don't know if anyone is interested to go further into details. So I see we have only a few people watching. So how many of you are interested into code itself right now? Because I'm not sure if if it's worth it to show anything. Okay. Well, I just wanted to... This is very important. I mean, those three examples, I think, are enough to understand that testing is just a concept and a framework matters very little. And in all languages, different languages, it will be all the same. So if you look at displays, and let's pretend that we have no hatchery and we have no chicken and we just know the specs. So we have chicken tests, and when we have chicken tests, the core object to create chicken is hatchery. And when we need to create chicken, we do it through hatchery. And so we created a hatchery. It's a test fixture. It might not be clear what it is, But basically, this is an XUnit's way of doing things. When you write it like this, it means that what you have in here, it will carry down in here. So it's a bit confusing. Yes. So if I go to the fixture, you see I have Hatchery. And my test fixture is just creating a hatchery. And here, I say that I have my fixture. So this is the object that I passed through here. And if you saw it here, it carries a hatchery, a public hatchery. And so since it had a public hatchery, by passing it here, it means whatever I put here, I can pick up from the constructor. And so I can set it in here. That's XUnit's way of creating a more complex object and passing it through a test setup. Basically, test setup for XUnit. And then we test. We pass in stuff. You see that we passed in worm weights, a chicken type, and expected count. In this line, you can see that. And no-brainer. It has input, so it has to be a theory. And then we have class data, type of chicken. So it's basically the same thing as here, but written in a different format. You can either do inline data or class data. So if I open this, you can see basically exactly same thing as you saw in inline data for XUnit. So those are the two things of how you can pass in parameters in XUnit. And imagine you didn't have implementation of Hatchery, and it doesn't matter. You just create something that you don't know how it works in here. Sorry, not in here, but in here. Not in here, in here. No. In here. You create something that you don't know how it works. It can be an empty class, it doesn't matter. It just needs to implement a certain interface. So if I go here, I created a hatchery, and I simply know that a hatchery is like a factory. I pass in a chicken type and it returns me a chicken. So a hatchery needs to implement this interface. And as long as I have a hatchery which implements that interface, I'm good, and I don't need to know how it works, how it implements. It just does the thing. And so I can then model that my journey, my setup for test starts with creating a chicken. And then I create worms. And after I created worms, I do the act step. This is setup, and this is act. My act means I lay eggs. I lay eggs by eating worms. And so I ate worms and laid eggs. And this is the output. And I know that chicken can lay eggs. I don't need to know how he lays eggs. I just know that he does. Or she. Probably she. It's a rooster otherwise. And so, lastly, we check if it worked. We check the same thing as in the slides, that eggs that a chicken produced should not contain undefined eggs and should all have, and the list itself that was returned should be as expected, and the expected was 5. So if it eats this many worms, it should return this many eggs. And that's what the test did. So setup, act, and assert. Those are the steps. Welcome back, Roloff. And other things are very similar. We create a chicken, we create worms, we say chicken lays eggs by eating worms, and then we compare if result is as expected. Nothing special. The setup methods that I had for this test suite, and this is the whole thing. It's a test suite, and everything like this and then this is a test case, is essentially not necessarily to show how clean tests are supposed to be written, but how every kind of step, every possible step in a test can be done in a different framework. So this is how it's done in XUnit. Facts and theories for marking a method as a test method. Test. Oh crap! This is this is XUnit. That was NUnit. So facts and theories to define how the test cases, inline data and class data to define the input, and then dispose to cleanup test, and parameterized tests or empty tests to pass a test fixture. Parameterized test if test fixture is complex, and test without parameters if it's more simple. This kind of test will be called once. This kind of constructor will be called once, and if I had a constructor without parameters, it would be called every single time a method is ran. Not always needed, but sometimes needed. Now, if we look at another one, and this is NUnit, absolutely similar. We have test fixture. I don't know why I put theory. I think it's because I have this here. It shouldn't be here at all. That's a mistake. Theory is not needed, so ignore it. Imagine it's not there. You have a test case, and it's all that is needed to mark method as a test case. It's either a test or a test case. But differently from XUnit, you also need to mark a class as test fixture. Hello, Hyper Wraith. How do you do? So this is a test suite. This is a test case. And as you can see, if we compare, the innards of a method are exactly the same, 100% the same. There's no difference. And that's why I said that it's BS when somebody complains that you don't have that you don't have that you don't provide which test framework you use for your tests. I mean, the concept is the same, and knowing the concept is enough. And are you sure that you don't need test fixture attribute? I always thought you do. It's really strange that if it's optional. Really strange. But okay. So we go on. Okay. This is NUnit, by the way, so it's really strange. We can of course test it and see if it's really like you said. I'm curious. Anyways, if we had a parameterless constructor in XUnit, in NUnit it's one-time setup. Sorry, parameterized constructor would be one-time setup. Parameterless constructor would be setup, means it gets called every time. This gets called once a class is initialized, once. This gets called after a class has done running all tests, and this is being called after every test is done running. All right, nice. I didn't know that. We all learn. And lastly, the most ugly testing framework there is in .NET is MS tests. Why is it ugly? Because you see, you need to say it's data test method and then provide a data row. And then another option is to give it dynamic data and based on a name of a type, which is just quite ugly, I would say. Quite ugly. It actually requires a string here. I just put it because I wanted some strongly typed things. So MS test is just dirty in my opinion. I have a bias against it. I might just do. And I'm pretty sure for MS test this is mandatory, regardless if you mark stuff with test or not. And yeah, so same things. The problem here is that you have very verbose attribute names like test method. I mean, instead of just test, you have to write test method, and then you have to write data test method, which is really derp, and not a clean way of naming things. And then you have test initialize, class initialize, which this is ran once for every test. This is ran once for class for the whole test suite. This is ran once every test is done for every test completion, and this is ran for the whole test suite completion. And yeah. Also, let me know if you have any questions. So how do you actually include a test project? If you're using Visual Studio 2017, you won't see all those templates that I do see now. You'll only see unit test project. That will be the only one you see. But so after you include this project, you have to add nuggets for NUnit, XUnit, because by default it is just MS tests. I also noticed that it's .NET Core for others, and actually they're supposed to be standard. They're normally standard, not .NET Core. That's also a bit odd. What's this that I have here? I have .NET Core, so I will pick .NET Core. So when a small thing about the structure. When you have a proper project and with source and tests, you might start mixing the two in your source, in your repository, in your project structure. And it's wise to have it split nicely placed in where it belongs. Tests in test project and source in source project. I misplaced it right now, so I'm moving it here. So I placed it in a different location, and now it doesn't exist. So I need to re-add it. So I'll duplicate the structure of my project. So I have those two, and in the source folder, I add a project that exists. And it exists in, where does it exist? I don't know. Let's see, recent projects. C repos, OP lessons, OP lessons. Okay. Add existing C repos, OP lessons. What the hell? How can it show that one that doesn't exist? C repos, OP lessons, OP lessons. It should show up. What the hell? Oh, okay. It was in documents repos or something like that. Anyways, so we existing project, documents, repos. I'll just copy the path. I'm failing badly now. Add existing project, this one, source. Yes, please. So we just re-added the project. You might also need to change the path sometimes if stuff is solution root, but doesn't matter. So let's test if your theory is correct. So I add NUnit test project. Where is it? Here, NUnit. .NET Core. I call it the same name as my project name, and I suffix it with .tests. So I say lesson playground .tests, and I pick a path to the test folder. Then I say create. And voila, you were correct. It has no attribute above it to indicate it's a test. Now I wonder if the same applies if I do it for .NET Framework and add NUnit as a nugget package. So let's try it. Because I usually deal with legacy stuff, and it does not include .NET Core. So not class library, but unit test project .NET Framework. I will call it playground, lesson playground tests net, and I'll put it in the same, I put it here, okay. Create. And let's see what happens if I manage nuggets and add NUnit. It's a bit tricky to get NUnit in the project, because not only you need to install NUnit, but you also need to install the runners and adapters. And adapter. And I hope I didn't mess up. Now it says, right, I don't care. Manage. Let's update stuff. It's a bit of a pain for those who are starting out to update everything. I mean, to set everything up. It really is a pain. It can be tedious and not work right away as you expect it to. So always the best thing to do is to just update everything and install all that you should install Now we said we are not making this like that, and we said we're making this like this. So using XUnit, assert, pass, and so I don't need this. So let's assert is true for true, and this should light up as green. Let's try. So if I, and it's also a bit weird, how do you run tests? So you need to go to tests and run to run all tests, but first you should probably just see which tests you have discovered. So you need to click this, Test Explorer. Now with Test Explorer, you see all the tests that your project discovers. I'll rename this for .NET, and this one for core. We don't need setup. And if I rebuild, because sometimes they don't recognize it, I also don't know why we have two .NETs. What we'll see. And why do we have so many random errors? I don't know. If we rebuild again, implement, rebuild. Okay. And you were correct. In this one, it still recognizes it. Can I try one more thing, which is, so let's run the tests and they should all light up green. No, what does it mean? There were build errors. Were there build errors? Succeed. Okay, failed. Why did it fail? And why doesn't it come up with an error? That's a good question. Clean, rebuild. Really strange. What's the output? Duplicate attribute. Let's unload it and let's inspect the project. Oh, nope, not the project. Duplicate attribute. We had some place open where it said something about attributes. Yay, thank you. Well, okay, it doesn't matter. Actually it does, and I want to fix it. Okay, good, now it gives build error. Duplicate definition. Lesson playground test assembly info. Where is this even coming from? Okay, sure. Auto-generated. I don't know. It says duplicate, so we delete. And it keeps on appearing here. So weird. So weird, what the hell? Okay, let's run this one. Okay, this one passed. Let me try to add one more. Is there a standard? Because usually when I work with tests, I work with standard. Test and standard. Core. .NET Framework. No standard, and if I choose core, is there standard there? There is no selection. Okay, so if I rebuild this build, okay, this one built. I don't know why that one is messed up. I mean, it's the same thing, so it doesn't make sense. So it got corrupted somehow, so the best thing to do is just delete shit and rename this as it should be. And don't forget to change the namespace. It changed, good. And don't forget to change where it is. And then you need to change this as well for the solution, for where the test project is located. Test playground, test.net. Core. Oh, right. We don't have that one. But this one is called lesson playground tests 4. Save. And if we reload, I've messed up probably. I'll just re-add it. Test core, this one. Okay. If I rebuild, it should reappear. And if I run, it should succeed. So this is how you set up tests, and this is how you run them. And indeed, you don't have to place an attribute for the test class as well for NUnit, which is a good thing. So NUnit is probably the best choice if you want to test stuff in general. Second best choice would be XUnit, and the best choice would be XUnit if you like object-oriented design more than other things. And MS Tests, it would be... I don't know who would choose MS Tests, to be honest. It's just ugly. Does anyone have any questions? In that case, I'll end the lesson and thank you everyone for watching and see you next time. Bye bye.